Hey there, ladies and gents. This is Mr. Dicken coming at you from the Mathematics ARC, the Resource Center. For this video lesson, we are going to be talking about solving radical equations. So radical, again, is a square root symbol. We're going to start off today just by assuming that they're all square roots. Later on, we will get into higher degree radicals, so like third roots, fourth roots, so on and so on. But today we're going to simply deal with square roots. Now, when we talk about radical equations, our variable is going to be trapped underneath a radical. And in order to undo a square root, we're going to have to use an inverse operation. So just like multiplying is the opposite of dividing, adding is the opposite of subtracting, squaring something is the inverse operation of the square root. So we're going to have to keep that in mind. As we go through, we're going to have to make sure that we check for extraneous solutions. These are solutions that work out for the equation, but when we plug it back in, it might not go through. So let's take a look here at number one. Number one, I'm seeing my x is trapped underneath the radical. So my first order of business is to get the radical by itself, and then I can square both sides. So to do that, let me kick the 4 to the other side. So I get 1 equals the square root of 5 minus 2x. At this point, we can square both sides. Remember, whatever I do to one side, I have to do to the other. Over here, 1 squared is just 1. And then if I square a radical, what's going to happen is the squared and a square root will nullify each other. So I'm left with whatever is inside the radical. So 5 minus 2x. At this point, I'm going to work to solve for x, so we'll subtract 5 to the other side. So I get negative 4 equals negative 2x, so x equals 2. Now, before I can be extremely confident in that answer, I need to just plug it back into the original function to make sure it holds. So my original function was 5 equals 5 minus, this would be 2 times 2 plus 4. So essentially I just plugged in 2 for x. 5 minus, that would be 4 is 1, square root of 1 is 1, plus 4, yep, that checks out. That is 5. Therefore, x equals 2 for this one. We might see scenarios in which we have a radical on each side. Well, in this case, the radical is already isolated, so if I square one side, I need to square the other. Just like we discussed on this previous problem, squaring a radical is going to knock out the square root, and you're just left with the radicand, or whatever's inside. So I have 2k plus 13 equals 1 minus k. We'll bring the k to the other side, and the 13 to the right. So when we do that, we'll get 3k equals negative 12. So I added k and subtracted 13. We'll solve for k, we get negative 4. Now, just to be sure, we're going to plug that back in to our original function. So 2 times negative 4 would be negative 8 plus 13. Negative 8 plus 13 is 5, so rad 5. Over here, 1 minus a negative 4. Well, minus a negative is a positive, so that's really 1 plus 4. Well, that'd be 5 as well. So the left side works out to equal the right side. We're good. We might see scenarios in which we have more complex problems where we end up getting a squared, an x squared value, and that's going to require us to either complete square quadratic formula or factor and solve, which is most likely going to be the case. So number 3, let's go ahead and square both sides. We'll get 5 plus 4n equals n squared. At this point, we want to make sure that everything is over to one side of the equation, so we're going to set it equal to 0. That's going to help us in factoring and solving. So if n squared minus 4n minus 5 equals 0, and now we can factor. We should be professionals at factoring at this point in the semester, especially given our previous unit. Numbers that multiply to be a negative 5 but add up to a negative 4, we'd have a minus 5 and a plus 1. So my two answers that I'm getting are n equals 5 and n equals negative 1. Now I need to plug both of those back in to double check. So let's plug in 5 first. Square root of 5 plus 4 times 5, does that equal 5? Well, 5 plus 20 is 25, square root of 25, yep. So that one works. If we plugged in negative 1, we'd have the square root of 5 plus 4 times negative 1 equals negative 1. Well, the square root of anything is not going to give me a negative answer, so I know it can't be negative 1. So this is going to be what's called an extraneous solution, or ES as I like to abbreviate. Last and final type of problem that we're going to see. We have a radical on one side, maybe a binomial on the other. A radical is already isolated, so we can square each side. So now we're going to get 3n minus 6. Again, the squared and the radicals knock each other out. But over here, we're going to have n minus 2 quantities squared. That's really n minus 2 times another n minus 2. So we're going to have to distribute out that right side. That's going to give us n squared minus 4n plus 4. And just like before, anytime we have an x squared or an n squared and a plain old linear n, we want to make sure this thing is set equal to 0. So I'm going to take everything on the left side here, kick it over to the right. So that's going to give me n squared minus 7n plus 10. At this point, we can factor and solve. Two numbers that would multiply to be positive 10 but add up to negative 7 are negative 5, negative 2. Therefore, n equals 5 and n equals 2. We can write those in whatever order we choose. And just to be safe, we would go back to the top, to the original function, and we'd plug in 5. That'd be 3 times 5. 15 minus 6 is 9. Square root of 9 is 3. 5 minus 2 equals 3, so that works. 5's good. We plug in 2. 3 times 2 is 6. Minus 6 is 0. Square root of 0 is 0. Equals 2 minus 2, also 0. So those both work. We don't have any extraneous solutions there. As always, if you have any questions, do not hesitate to reach out and ask for help.